2016. That's where we started at the time. And at the time, DevOps was very new. And everybody wanted to learn about this and so on. Today, 8-9 years later, well, DevOps is household name. 80% of organizations already implement DevOps and to some capacity. And well, it's becoming boring, right? Like everybody's using that. But there is some disruption. And this disruption is AI. And I think most of the people don't even realize yet what is really coming, because this is really moving very fast at this point. My name is Kaminski. I am one of the co-organizers together with Willy, with Naveen, with Martin, and with Ilse. So we welcome you to today's session. The session today is going to consist of two parts. I'll be talking about AI-native software development lifecycle. This is what I'm working extensively at WorkSafeBC as director of Advanced Technology Solutions Department. This new department that was created a year ago already. And primarily, we are looking at emerging technologies, everything that is new. Obviously, AI is the most important at this point, but everything else is a fair game, including blockchain and so on. So this particular presentation, I will start with the AI-native software development lifecycle. It is based on my upcoming book. Within the next 2 weeks, it's going to be published. And then Chris from Microsoft will be talking about how this could be implemented using tools that Microsoft is offering today. All right, so let's start. So first of all, the uncomfortable truth is that a lot of people think that, well, if the organization adopted GitHub Copilot, then we are done. And you know, productivity is going to be increased by 20–30%. Everything is hunky-dory. But the truth is that's not true. That's not really happening. Many organizations actually find out that the developers actually becoming slower, not faster. And the reason for that is that they go and start checking the code. And by the way, what was actually generated? Who is going to maintain it, right? We hear this actually all the time. But that's missing point. The issue is not really about one particular element in delivery of the software. It's not just one tool. Developers were never block in entire software development lifecycle. The developers, according to research, spend between 8 to 15% of time writing code. Everything else is meetings, it's debugging, it's documentation, and everything else. Reality is that even in the best organizations, only 15% is spent on delivering new features. So if we implement GitHub Copilot as just one thing, and everybody thinking that it's actually everything is working well, and we use a traditional software delivery, and we graft AI somewhere in the top, not only as a tool to help us write code faster, but also to solve certain problem. The issue is like we are putting a Ferrari engine into a car. It's actually not going to make us faster because it does not address the core issues that we still have, which will be like still traditional testing that is happening over there, a traditional deployment, traditional maintenance, and traditional debugging. And obviously security gates and so on, so on. So what BCG research found that 74% of organizations do not see really tangible results and benefits and value from AI. And the problem is, again, because we all, including myself initially, we were just thinking about this in the wrong way. We are thinking that we just continue as previously, and we will start adding AI on top of that. And the reality is different. When we start crafting solutions, we need to start thinking about what AI is going to do to solve the problem that we want to have for the business or business solution. So we start about thinking first about AI, and the code comes later. Because then it is actually, that's when it becomes really AI native development. I'm going to show you what the benefits of this are. So what is the distinction between the traditional AI augmented? I'm calling it traditional. It's not traditional. AI augmented software delivery. So using GitHub Copilot, for example, versus AI native. So first of all, AI augmented is that the humans write the code, and AI is just assisting, right? So GitHub Copilot is an example of that, or Cursor, or any other tool. And we still got a traditional software development lifecycle phases for good reasons, because obviously there is a humans involved and humans make mistakes. So we need to have those phases and handoffs, and we need to have gates to ensure that the quality and security are implemented. Again, many organizations claim that, okay, with GitHub Copilot, or tool like GitHub Copilot, our productivity is going to increase by 20 to 30%. And as I said, that's not reality at this point, but that's not enough. I mean, if you just yourself, if you actually use ChatGPT for solving certain problems, are you just 20 to 30% more productive? I bet you're not. You are actually much more productive. So what's wrong with this picture, right? Since we've got the same processes, we are supposed to be faster. But again, as I said, in the entire life cycle, even if you write your code faster right now with one of these tools, it does not, it actually pushes the problem from one area to another. And the software delivery is still going to take 8 months or whatever it's taking. With AI native, so there's a future state. AI generates and humans orchestrate. I will explain what it means. And it is, and we do this in the continuous parallel cycles. The productivity increase is not by 20 to 30%, but the potential is by range of magnitude, 5, 10%, and actually it could be more, which we see already at this point with some of the experiments. So this is entirely new paradigm, which is extremely difficult to think. And I can tell you, like I see, for example, developers who are using AI at this point, and they should be becoming experts. And recently I've seen code that was created. One of the developers spent about a week creating exceptions for errors that were generated, potentially could be generated by the application. So the end user has a friendly error message. So it took about a week to have all those exceptions, you know, when there is error, then, you know, this is the text that you're going to display, and so on, so on, so on. And guess what? If you feed this particular error message to AI, to LLM, and you ground it properly, like you are, let's say, friendly developer who explains to the user, who is business user, who doesn't understand technology, in a friendly manner, what this error message means, it will actually do that. And it takes 5 minutes, literally 5 minutes, not 1 week, right? So we have to completely start thinking in totally different way that we did it until now. So there are 4 fundamental shifts that are happening. So first of all, we are moving from imperative to declarative. So we should stop telling LLM how to do the things. We should start saying what you want, and LLM is going to figure out how to do that. It's similar, like, for example, just imagine that you build an AI agent and you say, I want that you cut with a knife something. Well, if you are cutting bread, that's okay. But if you are cutting, for example, metal rod, that's most probably the wrong tool. Agent needs to figure out, depending on the job that you are asking, what tool to use. In this particular team that I'm working with, we are actually generating or creating these tools, and we are creating actually those agents. So developers could actually use that, use them. So so we are moving from imperative, from what we did for the last 50 years, where we use software languages that we actually instruct the computer what to do. We actually move right now from saying that, we just say, I want this, and AI needs to figure out how this is going to be done. We are also moving from code as a central artifact to prompts. The prompts are actually the one that make AI deliver something. And prompts are becoming the new IP, intellectual property of organizations, not the code itself. The prompts are also treated as any other asset, similarly like code, needs to be versioned as well. And I will be talking about this in a moment. There's a whole hierarchy of prompts that needs to be in place. Shift 3 is a static to self-evolving applications. If you think about the application that you normally do, so let's say you release something today, it will become static and will not change until the next release, which might be next 6 months, where you will be just doing some updates or fixing the bugs. With AI native approach, it's different, because if your prompts are outside of your code, that means that the behavior of the particular agent or AI is going to change depending on how the prompt, what the prompt really does. Which means that almost on daily basis, you could actually deploy a new set of prompts and change the behavior of application without redeploying the code. So think about this, how powerful it is, because you don't need to go through security reviews. You don't need to go through all deployment, change management groups, change management reviews, and so on and so on. There's a huge effort to actually redeploy application. With this one, you can actually change the prompt the same day and have it like within 2 hours actually application working in the production. You still need to do validation of the prompt, obviously, because you don't want to have some injections of or having some silly things. It's become a little bit more complicated because there is a whole hierarchy of prompts that they depend on each other. So there's a new role, the prompt engineer, that really need to understand what the consequences are of changing these prompts. But it's actually becoming a little bit trivial. And what is most important, these prompts are written in natural language. So the people, like business engineers, business analysts, they can actually make these prompts or changes those prompts. So people with that type of mindset. I'm not saying that everybody should have access to that, because obviously the application will become unstable. But it's actually changing completely the way how we work, from learning the languages, development languages, to actually using natural language to describe what needs to happen. And then we are moving from sequential to orchestration. So potentially there's several benefits that might happen, where one of the ways how you can orchestrate the agents is that you allow to work in parallel to develop the software, which potentially actually is going to speed up the delivery even faster. So what changes? In traditional software development lifecycle, we really build this around humans and humans' weaknesses, right? And limitations. So we have sprints in Agile, for example, that we protect the team for 2 weeks in order to not to have any changes to the requirements and the focus and doing the proper analysis and so on. So we protect the team for 2 weeks. Nothing can come in, nothing can actually change. And then we work on stories, right? Which stories describe what the application is supposed to do. The problem with the stories is that, unfortunately, often they are pretty ambiguous. Even if you write a story according to Agile, using all the best practices for writing the stories, it's still not enough information. If you think about, for example, employer account, if you feed this to LLM, what you're going to get? Well, something generic, right? But in your organization, employer account means something different than what generic AI might know. So what is important that we have to start thinking and providing information to AI in totally different way. There cannot be any ambiguity with that. That's the reason where a lot of organizations fail, because they try to actually do, we call it naive type of prompting, very simplistic, right? Without really understanding what the consequences or the way how AI really processes information. And we've got the phases, obviously, because as I said before, because of those limitations, we need to make sure there are some gates, there's security reviews, there's performance reviews, and so on, so on. And then we've got the process, right? So any change that humans do is risky. So people make mistakes, and obviously this needs to be validated. So just think what would happen in an ideal world where we don't have those limitations. And what is really happening with AI as well, there is a real constraint shift. This is really, it's not anymore about how many developers we have and how the way how our capacity is going to increase and where are we going to find these developers, you know, and skill sets and so on. And, you know, a couple of years ago, there was a good run where a lot of developers was jumping from between jobs and so on. Everybody was looking for developers. And that obviously created a lot of disruption for many organizations. But the capacity is not an issue anymore. It's not capacity, it is actually how effectively you can orchestrate these systems, which means that you still can have the same amount of developers that you have today, but you're going to work and deliver much more, or many more applications and solutions that you could do actually in the past. So the bottleneck is no more the capacity itself, it's really the human judgment and expertise. We need to have the right people who actually can converse with AI systems in proper way in order to achieve the goals that we want. So let me talk briefly about AI-native software development lifecycle. That's something that my department is actually adopting at this point. It's not entire organization, by the way. There are some people from my organization, so I just want to qualify. We are the experimental team. We actually go through this, and so far we got very good results. But that's just what we do. So this is how it looks like. I'm not going to get into too much detail, but there is a several phases here that you can see. The first one is really discovery. And it's not exactly the same type of discovery as it was done before. Because, for example, in agile teams, you start with some general requirements with some features and stories and so on, and then you discover stuff over time, and then you change and so on, everything's hunky-dory. Here, the discovery is really important because this is the time where you create so-called context prompt. So we've got a new role, it's called context engineer. I'm going to talk about this in a second, who are creating really the boundaries for entire application. What it means, the context contains all the information that is required to build the application, including what we build, why we build. It's extremely important for AI to understand why we build this. Like in normal world, right? When you start the project, you don't need to explain to the team, just tell to the team once, you know, okay, we need this for this particular purpose. Here, the system needs to really understand why you have it, because it might come up with even better idea to solve this particular problem. So we don't tell anymore how to solve the problem. AI needs to figure this out, as long as it's properly prompted. So the context engineering is one of the first one. Then we've got the architecture. Again, this look actually different than a normal architecture. It's not just system architecture. It is the prompt architecture and hierarchy of prompts, agents that will actually work and how agents are going to collaborate. Then you've got a generation. That's what some people call vibe coding. I'm pretty sure that a lot of people don't like this term, but agents could potentially generate the code over there. There's validation, which is AI-based type of testing of the applications, deployment, operations, and evolve. The evolve is extremely important because system learns from its behavior in production. So you might actually find out that certain customers, certain segment of customers is coming a certain period of times and they behave in slightly different way. And you might actually optimize the system depending on the outcome by changing the prompts. So that's important. You don't need to redeploy the application. You just change the prompts and the application starts behaving differently, addressing actually the issues and constraints that are being detected. But the bottom line is this, there are really two parts. The left side is really about the prompting, because these prompts are updated constantly. As a matter of fact, every single phase that you actually see on that screen is actually using the context, a context prompt for the grounding. So in other words, entire system and whatever number of agents you might have that is helping you to build the applications, they are all using the same set of prompts. Or say the same prompt, which is the context. So creating the boundary around that, which ensures the consistency. And then the other artifacts, obviously, we still have a code. So it's not, I'm not saying that we are not doing the coding anymore, but the coding is becoming less important. The primary shift is really to the prompting. So that's how it looks like. As I mentioned, discovery and context. So in that particular phase, we're doing the domain modeling. We are doing the RAG, retrieval augmented generation design. We are doing also the context repositories. What is really important as well to understand is that when we develop these context repositories and we spend time to create this particular document that we call context prompt that describes exactly the behaviors of application, but also every potential constraint. It describes also technology that we want to use. Well, for example, in our case, we are using Microsoft Stack, so we are using Azure Foundry, so we can define this over there. But what is important as well is that we need to very exactly specify what we mean, so AI can really understand it. And the other part as well, which is different than in traditional world, AI need to understand what are the positive and negative examples. So we need to actually feed it at the very beginning, so the system will be able to generate the solutions properly, including the not only positive but also negative examples. The next phase is a prompt architecture, as I mentioned. So it's a hierarchical prompts. Their variables within these prompts are embedded, and there is a potentially relationship and link between these variables, between these prompts. So they cascade down, right? So you might be feeding something into LLM, and LLM is going to respond with some answer. You put it into variable, and those variables just go across the board. The other aspect, which is also important, is that there need to be dynamic variables, because you don't want to redeploy the code every time you add new variable to your prompt. So the system needs to discover the variables itself. Phase 3 is orchestration. That's the development. So it's multiple agent coordination generation cycles. Phase 4 is intelligent quality. So autonomous testing, self-healing suits, and so on. I just want to mention this is really very powerful and important, because in traditional testing, people got the limits, right? First of all, how many tests we can actually test or perform, right? Because there is limited time. The second thing is how many test cases potentially could exist. How many permutations of specific actions could be? Well, so we have to focus. We have to obviously throw away a lot of these tests that potentially might discover very subtle ways and edge cases. With AI, it can actually generate automatically. Now, also remember that we have to spend a lot of time rewriting those tests. In ideal world, we've got the best developers in the world. We don't need testing because the quality will be perfect. Mm-hmm. It doesn't happen, right? So for that reason, we have to have tests. But in this particular case, AI could actually do and generate not 50 test cases, can generate 1,000 cases and can execute. So what? Great, can do it, no problem, right? And then we are increasing the test coverage, not only from the perspective of how many tests we have, but primarily that the application is really doing what is really important. And what is important, these tests are actually generated from your context prompt, right? So that's important, because what you describe what the application is supposed to do, now the tests are going to cover. Automated deployment, obviously, that's extremely important as well. As I mentioned before, we separate the code from the prompt. So there are two set of pipelines, one set of pipelines for prompts, the other one for the code. And then continuous evolution. The system learns. System might actually provide information to developers about the performance of the application, and then provide suggestions, or in the future can actually update the prompt itself. And depending obviously on the risk level and application type, it could be autonomous, or it could be sent to humans to do approval. So context engineering, as I mentioned, this is extremely important. In my group, we created, or I created, really entire training for our team. It's based on this, on my book. So I come up with a 13 segments, each 1 hour. And so far, actually, yes, it takes 1 hour to really explain that, to go deep into that. But this one, context engineering, has its own section. It's an entire hour just to talk about that. It's so important. And in this particular case, you know, the context repositories contain things like domain vocabularies, and this is extremely important because what does it mean? Like, as I said, employer account. What does it really mean, right, within the organization? What are the relationships between entities and how to build those models? That's the context engineering. So business rules, regulations, workflow definitions, and stakeholder intent, explanation why we do that and what really the intent of the application is. So there is a new role that we call context engineer. The easiest way to transition to this one is most probably for product managers and product owners or business engineers because they've got already a lot of skills. But it's slightly different. Not necessarily. It's, they need to also capture the domain knowledge, but it has to be in a machine learning or machine readable format. Now, I said natural language because that's where you start. You can actually use natural language, but natural language, unfortunately, is ambiguous. So and then the other problem as well is if you end up with a document describing the behavioral application that has 120 pages, and for every step, if you need to feed those 120 and encode it, it will consume millions of tokens potentially. So there are techniques to address that by prompt compressions, for example, or caching and so on. But what is really important, the best way is to really transfer that natural language or convert natural language into YAML format or JSON format, because then the ambiguity disappears. And the system will be very quickly able to detect that there is some information missing. Obviously, designing reg architectures together with another role that is called knowledge architect, as well with AI architect, and knowledge graphs development, validating AI, the AI to understand the business concept, and then maintaining the living context repositories. Again, it's extremely important because the very first time you're going to spend some time developing those prompts, these prompts are later reused in the new projects. So the system can actually discover them. And including your vocabularies and everything else, it's way faster. So it's a compound effect of the delivery, on delivery speed. So I was talking about the prompts, right? The very first prompt was the context prompt, which is the most important. But then there is the rest of the prompts that also need to exist. And this is done primarily by the new role that's called prompt engineers. They need to really understand how to build those prompts. But even more, it's not just about the relationship between these prompts, and which could potentially become complicated, but also how many tokens these prompts are using, how to optimize them, and just please remember that over a period of life cycle of application, the prompts will be decaying because LLMs will be changing, the cost of the LLMs will be changing, and so on. So prompt engineers are actually the ones who really understand that, and they constantly fine-tune these prompts. So hierarchies like master prompts, which is system-wide, for example, like what type of architecture we're going to use, what type of frameworks we're going to use, what language we want to develop this in. Domain prompts, which is specific, contain the specific domain logic and business logic. Module prompts with specific feature implementations, and we've got also function prompts for implementation details. What is important, as I mentioned before, prompts are really new code. So that means that they are versioned, they are tested, they are optimized, and they are reused. So here's an example of multi-agent orchestration. There are really two levels or two planes where this is happening. Level one is delivery plane, where are potentially multiple agents. Just imagine the near future, the developer will be sitting actually in the front of the computer, and on the dashboard, they will see 6, 7 different agents actually doing the work. And because in your context prompt, you specified what the priorities and conflict resolution is going to be. If one of the data agents, for example, detects that there is a problem and tries to actually do a specific solution, but security agent is identifying that there is an issue, you cannot do that because there is going to be some SQL injection or something like that. Well, guess what? Orchestrator is going to say, well, security is right. So security, data it needs to actually change and the solution or design. But if the conflict cannot be resolved, it goes back to developer sitting in the front, and the developer is really making the final decision. But the most important is that developer is really doing the orchestration. The second level is really when we build the solution for the business. So what my team is doing, we are building those smaller agents that actually help with the delivery. But once they are in place, the business teams can actually use these agents to craft solutions. Now, what is the powerful area or concept here? And our team is actually building at this point class of agents that we call Doc Nexus. And this particular agent is to guide through collecting of requirements, for example, when we do the statement of work. This particular case in our organization can take a week or 2 weeks because the people need to meet, there is a business might not have all information, and there's a quality of that as well because not everybody understands in depth that business and so on. So it has to be guided through specific steps. So for statement of work, we create one agent called Doc Nexus, but for statement of work, we had this entire set of prompts because it has very specific workflow, very specific format. It's going to check against organizational goals, and then it's going to say, sorry, this doesn't align with organizational goals. You need to change that, right? But if you change the set of prompts to another one, now you can actually do business cases exactly the same way. Or you can do privacy impact assessment documents and workflows. Or you can do requirements or contracts, whatever it is. One agent with multiple prompts. So one class of agent implements multiple agents by just changing the prompts. So it's really extremely powerful. You deploy it only once. So here is an example of that potentially could be that multiple agents actually work together. You build them, you create a solution, you give it to the customers. But those agents could be reused in other solutions as well. So they don't just exist in this particular one solution. So what are the economics? Very briefly. Traditionally for application with 15 developers, that takes about 18 months, costs about $4 million. With AI-native development, you can have it about $700,000, and you can do it with 5 people within 6 months. So 5.7 cost reduction and 3 times faster delivery. But there is other aspect of that which is really important, which I didn't put on the slide, but it's in my book, which is token economics. It's completely changing the way how the return on investment organization needs to be looked. Because traditionally, we've got a fixed cost in our teams, right, delivery teams. So every team has certain cost. Doesn't matter if developers are writing new features and adding new value, or they are sitting in the meetings, you still pay the same amount of money. With this, token economics actually going to increase, it's going to change from the fixed cost to variable cost. And it's so important to monitor these costs because they could get out of hand very quickly. So there are several metrics that actually change as well. So first of all, we need to look at how much time you can actually right now is going to take you to develop an application from, let's say, to the first prototype. And it could be between 80 to 90% faster than in the traditional world. 5 to 10 times faster feature delivery because of the improved speed. 60 to 70% reduction on bug fixes and time, and there is a 0 documentation that is required. I mean, who really likes documentation? And honestly speaking, you write the documentation, right? The moment you publish it, it's already outdated. So who is going to maintain it? We have to have teams and people, and everybody hates that. Well, the system actually self-documents. As a matter of fact, your original document, what the system is doing is your context prompt. It contains everything there. So you can extract every information from there. And it's real. And it's real because it corresponds what was built. It's not like, you know, you build something else and your documentation is talking about something else. So, so we are moving from developers to orchestrators, right? So there's a human side of that. So several roles are changing. So for example, business analysts or product owners are becoming the context engineers, developers become either AI engineers or orchestrators, solution architects become AI solution architects, and QA engineers become quality orchestrator leads. So it's totally different. And what is important, AI does not replace people. AI actually empowers people, right? Because now you can actually do stuff that you didn't have time before. The bottlenecks shift somewhere else. Bottleneck shifts actually to human judgment. Do we have actually people who can actually judge this properly? Do they understand the problem, right? So if the AI encounters a conflict, that you can actually make a decision. Domain expertise. Strategic thinking and orchestration capacity. So we can actually build more systems faster. So what skills are really matter today? Well, first of all, the skills that are going to really decline, that will be the syntax memorization. Doesn't matter what language you're writing in, right? Doesn't matter, you know, the software development languages were created for us to actually provide instructions to machines, to computers, to actually do something that we want. But remember, we are not specifying anymore how, we are specifying what we want. So we just need to do it in the natural language. Manual debugging is going to disappear. Code optimization details and the framework specifics are becoming less and less important. But what is becoming more important is the prompt engineering. It's output and outcome validation, system thinking, token economics, as I mentioned, extremely important, and agent coordination. So here is an example how, and this is actually part of my book as well, how organization could actually start implementing AI native development. It can take about 18 months, but it depends on maturity of organizations. On average, it could take about 18 months, I would say. First of all, foundation building, some pilots, creating some credibility, learning, because everybody's going to fail at the beginning, and there's not a problem with that. So we don't want to actually select projects where are too strategic or too critical initially. You actually want to prove that that's going to work. Months 6 to 12, you can actually start moving about 30% of your projects to actually doing AI native development. And then month 12 to 18, you actually should be at least 50% AI native and deliver and start achieving at least 5 times productivity. And what is important, it cannot, the technology exists today. Technical part is easy. The human side is difficult because we have to start thinking totally different way, right? There's going to be a lot of resistance. There's 6 levels of that everybody goes through, including myself. First of all is the denial, right? Like, I'm not reading AI documents. I'm not, you know, doing, and so on, right? Then we go to the next level, which is anger. What the piece of garbage this is creating, right? Who is going to maintain it, and so on. Then you go to bargaining. Okay, now I start understanding why this is needed, but, you know, our project cannot do that. Maybe you can do it later. Then we go to the next, you know, so there is several phases that everybody goes on to the last phase where actually is evolution. Like suddenly, I am actually empowered. I am way more powerful. I am almost like, you know, someone who can actually start connecting dots, which nobody could do before. We are living right now in more and more complex world. There is not a single person that understands everything. AI can actually support us, or must support us with that. A couple of common pitfalls. So treating AI as a better compiler, that's definitely not what it is. Insufficient prompt engineering. It is the naive type of prompting. I would suggest if you're thinking about this, really learn how to actually do the proper prompting, because naive prompting is going to, first of all, will not provide you the results you want. You'll be complaining about hallucinations. You'll be spending tons of money. And honestly speaking, bad prompt could be about 4 times or can consume 4 times more tokens as Gutmann. So the cost could escalate very quickly. Ignoring token economics that I mentioned already, and over-trusting the AI output. We are also building auditor type of agents that actually check what the output is going to be, and totally independent from the other agents they are building. So it checks against the context engineering and also other documents as well. All right, and so we can do tomorrow. I would say, well, if you want to start, my suggestion would be start with prompt engineering training, identify some pilot projects, build context repositories, and track different metrics. So key takeaway, AI augmentation is not the same as AI native, right? So it's a totally different paradigm. It's hard. It's not easy to get initially to change the mindset into that. Promise primary artifact. Potentially the potential velocity that could be increased by 5 to 10 times and is achievable. And we are shifting from implementation to orchestration and do it already now. So and I think that's what is really important. I don't know how many people know organization is called Midjourney. So Midjourney started 2024, 12 employees. The value of the organization was $200 million. 18 million per employee, not developer, per employee. For many organizations that are out there at this point, well established, they don't even know what danger actually is hiding there. Because there are some small startups somewhere there that nobody sees that is going to take them out of the business. Someone told me recently, and I believe that's true, there are 2 types of organizations. The ones that adopt AI, and those organizations, they are dead, but they don't know about this yet. Well, except obviously trades. Right, so here it is. It's really the more details about that is in my book. So if you want to give a gift to a friend of yours for the Christmas, or you want to spend a little bit of time during the holiday break, yeah, welcome to do that. The book is still not out. It's going to be in 2 weeks' time. You can actually join or connect with me on LinkedIn. I will let you know when it's available. All right, thank you very much. So
I have a couple of questions and some inputs. So the very nice presentation, very fresh and very true, right? But like in the second part, when you were talking about the processes, right? You determine, 7 types of processes. And I believe, like that you are missing one thing, because you are starting from the idea that the code that is going to be generated by the agents is a perfect one, right? And so basically, you are forgetting that we are not at the stage that the agents are autonomous fully, and that basically the role of the human in a loop, right?
Yeah,
is still tremendous. And so basically, when you have that 7 stages, right? No, that was the other one. But you can keep, this one. Correct. And so basically, you're putting all the stress on the prompt architecture, right? Like the prompts are building the application, right? But essentially, the code of the application is being generated in the phase of the orchestration, right? And so like you noted, that we shouldn't be trusted too much, to the AI. And so I believe, that these people who are working as the orchestrators, they should be actually looking into the code and seeing, like, is that code not passing that stuff to some quality agents or whatever, because, the quality agents can actually check the requirements and they can check the outputs and everything can be fine. But in the middle, the architecture can be rubbish. And also not only that, but also, so I believe, that the role of the AI or orchestrator is much bigger than, like that you put it here, that he is more responsible for the architecture than the engineers who are working as a prompt engineers, right? That's the first thing. The second thing that I wanted to disagree is that, but you essentially, like said, like that this is going to tremendously increase the productivity, et cetera, and you said that you can keep all the developers that you have in the organization, but essentially that's not what it is about, right? So basically, if you can actually make some things, like 7 to 15 times faster, and like the load, or like the projects that a certain organization is planning to develop is not going to go exponentially because someone has to finance that, right? So essentially what it means, like that, I believe I didn't read your book, right? But like what is missing here in this kind of speech that you gave is that there is going to be fundamental shift in the way how we build the software and in the roles. And so you depicted these roles. I believe, that the role of the orchestrator should be bigger than of the prompt engineers, and that that we are not still at the moment when we can actually neglect and so give everything to the agents. So someone has to basically look into the generated code. Is it structure? Is it like the architecture of the generated code? Is it good? And also, if I don't know, like if you develop the code in the previous the previous time, how the code was being developed, is that you cannot actually isolate debugging from the building or generating code here, right? And so essentially it's being called, I believe, evaluation or evals, right? And so basically that stuff is also going to go into that guy, orchestrator, right? Because, you cannot give responsibility to the agents and say, oh, the agents are going to generate perfect code. And so his responsibility is going to be to go through these eval tools and see, whether what these guys from the prompt engineering team, architecture, and then the context team, what they actually envisioned, is that actually happening, from the end to end, from the beginning to the output, right? And when I say output, I think, it's a generated code in this manner. Sorry for being...
No, that's valid questions. Thank you for those questions. So here's actually an example where we have to start thinking differently. Because what we are thinking, what we are talking about, you're thinking about the outputs. Yes. What the code was created and, how well it was architected and so on and so on. Well, I don't care how it was done. Because what I really need out is the outcome. What was really what we wanted from the system? Is it working or not? I'm going to get what I need or not? And I'm getting it with the right quality, with all non-functional requirements that I got. If not, just notice, it's actually infinite loops. It actually goes here and actually regenerates. It's a numbers game. Remember that, let's say that you've got an organization. You need to innovate today. You must innovate in order, if you are actually in a business that is competitive, you must innovate today. And let's say you decide to spend $1 million to actually work on 3 innovative projects, maybe 5 of those innovative projects. So it comes to about $200,000 per project. That's your cost. How many of those 5 is going to be actually breakthrough inventions? That's the traditional world. Now take the same $1 million, and now with AI-native development, you can, for the same $1 million, you're not going to have 5 experiments, 5 projects, but you can have 100 at the same time. What the probability of having a winning breakthrough project actually within these 100? It's actually way higher than it is. So the thing is that, is it really the number game at this point? When I hear those arguments constantly that, oh, this is spaghetti code, this is something that I cannot understand, and nobody really. Why do I care about this? I don't care because the system needs to self-improve if there is a problem. If I need to make changes, if there is a bug, I regenerate again. So I regenerate until it's done. But it takes me 2 days, not 8 months, where I actually spend a lot of time. And
can I ask another question here?
You've got a gentleman over there as well. Let's go to him.
How much time you have, right? So.
Thank you for the presentation. I just wanted to ask, okay, so on the architecture going to generate on this loop, you see all the prompts feeding in, but on the way back, after you operate, how for the next generation of prompt of the code, what artifacts do you use as input for that generation, for that optimization?
Oh, very great. There's a great question. So here during operations, we actually have a real-time monitoring. And the data is collected, and there is AI that is analyzing this data. Now, in contrast to, for example, if you're using Azure and you're using App Insights, how much information you can really get out of this and intelligently really see. With this, the AI can actually see and analyze way more patterns than previously. And what this generates from operate to evolve, it actually provides the input so the prompts could be updated correspondingly. So it's a constant improvement. And as I said before, the prompts will be decaying because the LLMs will be changing. There's the new models. There is the cost is going down. There is we see ChatGPT 5 apparently is worse than ChatGPT 4.1. Right? So if someone updated, you might not be getting this type of information. So you want to constantly really evolve the system. So it's not going to stop. That's why it's infinite loop. It's constant improvement. There's one thing I just want to mention as well, and that's blasphemy. I know it sounds like blasphemy. I don't know how many of you guys using Agile. Right. Okay. How many of you are aware of Agile Manifesto? 4 principles, right? They are extremely important. It's like I was one of the first people who actually I was using rational unified process before 2000s, right? And in year 2000 there was Agile and Scrum, and it was like, oh, that's a breeze, at least the common sense. Guess what? One of the principles says working software over comprehensive documentation. Not valid anymore. I can get working software within 5 minutes, but it's not going to do what I really want. Comprehensive documentation is actually there's one that actually going to actually generate this particular software. The documentation becomes actually most important at this point. You have time. I think Chris is waiting, right?
I think Chris is waiting. Yeah,
I'm still here, so obviously, if you want to have, if you've got any more questions, I'll be happy to answer.
Sounds good, Andre.
Okay.
Chris, thank you.
Thanks, folks. Quick sound check coming through, okay?
Yeah, perfect. We can hear you.
Excellent, excellent. Hey, folks, my name is Chris. I am a senior solution engineer at Microsoft. My area of focus is developer tools, developer platforms. I got a deep passion for developer productivity and developer experience. I am a 29-year software professional. I've been an Agile practitioner for over 20 years. And I joined Microsoft in 2012, and I've been a DevOps subject matter expert for our organization. Now, I just want to start by saying I'm glad that the topic just ended actually on Agile. But before I jump in, I do want to say we're going to do things a little bit differently here for a Microsoft presentation. No slideware, just raw thoughts and my views based on my experience and insights working with customers coast to coast here in Canada around the topic of DevOps. The reason I'm happy that that conversation just ended with Agile in the topic is because we are dangerously close to repeating past mistakes. In the era that Agile was becoming a thing, it was so scoped to dev teams that they quickly outpaced everybody else in their organization. Product management groups couldn't feed direction into dev teams fast enough. Quality assurance teams couldn't validate the work they were doing quick enough. Operations teams couldn't spin up environments and have them configured and secured quick enough. And so, yeah, it was awesome. It was working great, but the systems around development teams were gumming up, and thus birthed DevOps, right? And so we have to look at this parallel, because I'm going to be talking a lot about GitHub Copilot. I'm going to be jumping in. It's just, again, me, my raw thoughts, my views, and some tools demonstrating some practical use cases. But, you know, I've never seen anything like this. I've seen a lot of change in development. I've seen roles across the entire SDLC needing to evolve over time, but never anything like this, never anything this exciting. And so why is this topic of agentic DevOps becoming increasingly more important to remediate and to prevent making another past mistake similar to what we did in the era of Agile? GitHub Copilot started out as a code completion tool, a code suggestion tool. I'd be banging away in my editor and it'd pop up and say, hey man, here's what I think you got to do. And I'd accept it or not. And that was great. And then it shifted a little bit to saying, to being more about what if the developer could query and ask for what it wanted instead of AI just thinking. And it moved to that, and that was great. But now we're in this era of agentic development with agents, both paired programming with the developer and peer programming alongside of them in a fully autonomous way. So that's awesome, because it's going to speed up the creation of software, and it absolutely is. I've seen this across the country. It's fantastic. But what about the broken systems today? Andre's right. DevOps has become a household name, but how many organizations out there actually have achieved effective DevOps? Mediocre. I mean, there's plenty that have for sure, and there's plenty that are on that journey and continuously improving and doing their best. But in my role, in my 13 years at Microsoft, I've had the privilege of working with thousands of developers across hundreds of teams, and so few of them really have DevOps down pat to the point where they can flow change seamlessly. So what good is being able to create faster if we still can't provide that sense of direction in lockstep with development, and we can't validate the things that are built, again, in lockstep with development, and if we can't provide the environments for which we can experiment, build, and do the things that we do to need to get something into production. So AI cannot just be focused on the developer. Artificial intelligence needs to be applied across the entire software development lifecycle to try to maintain a consistent pace across all phases. And that's really what I'm going to be highlighting here, is just some ideas. What I love about this point in time is things are so fresh and so new. Again, I don't think this is one of the most exciting times to be a developer. And things are coming at us so fresh and so new that where there's gaps today, that gap will inevitably be filled either by us as developers spotting a need, or by vendors like Microsoft releasing new features. So let's talk about the value stream for a moment. This is one of my very favorite topics. I've had the pleasure of working with Andre in the past in and around the topic of value stream mapping. And if we think about a value stream, let's simplify it. We already know that all of the things it takes to have an idea flow through all of our teams and people to end up as a thing that people can put hands on keyboards and use. That's notoriously complicated, and it has been since the beginning of software development. And in this era where we're expected to go even faster, again, if we don't have effective DevOps, if we don't have our DevOps ducks in a row, we end up gumming up. And so if we think about a simplified view of the value stream, just simply let's bring it back down to planning, coding, testing, deploying, and operating, right? Again, there's a lot of hoops in between for sure, but let's simplify to that. What can we do with AI to speed up all of those areas? My short answer is, well, that's why this is such an exciting era, because really the limitations are our own creativity. We can use AI in the innermost developer loop to speed up anything from writing a line of code to writing a method. We can speed it up writing, libraries and art. Like it can impact our innermost loop and every loop outwards across all our roles, but we need to be creative right now to figure out how that is done because everything is so new and fresh. So how do we know where to apply AI? How do we know, excuse me, how do we know how it can best benefit our teams and how we build software? This is something that a value stream mapping exercise would be very powerful at. But bottom line, ask yourselves, where are we slow? Where are we prone to making errors? Andre mentioned this earlier. We're only human. We make errors. Where are we slow? Where are we error prone? Where's there high risk? What are the things that are painful and feel just like burden? What are the things that are grunt work? What are the things that, we can't provide quick enough? There's so many things that slow us down in building software. We need to be asking ourselves, well, how can we speed that up with AI? The organizations that I've worked with that have been most successful, they have this experimental nature to them of just giving it a shot and asking the question, in all that they do, can AI help me do this better? My recommendation in working with customers is simply this. When you're getting started, ask yourself how it can make me better at whatever role I'm in. Can it make me a better developer? Can it make me a better tester? Can it make me a better, PM? Of course it can. So when we look across planning, coding, testing, deployment, and operations, each one of those areas of the life cycle are riddled with challenges and riddled with things that slow us down. And so let's take a look at how being creative and just experimental can maybe give us some ideas on how to move forward and speed things up. So I'm going to share out my screen. And I'm going to start with a very quick overview of my demo environments. I've got two environments here. I'm mixing it up a little bit. The first is a Codespaces. Codespaces is for lack of a better description, a containerized instance of VS Code, very familiar to anybody that uses VS Code. This particular application, it's a pretty simple web app, but it's a modern web app. It's well designed, has a good architecture with separations of responsibility and concerns. And like any good repo, it has great information to the developer to run it and do what they need to do. So I want you to consider this application, well, let's call it Amazon for the felines. It's a storefront for cat fans that want to purchase things for their cats. And I'm going to give it a quick run just to show something here very fast. Full screen here. Okay, so I've got my front end running. Even in this installation, when it comes to what a great example of immutable architecture, like I'm running all of this containerized, very secure, very safe. When I actually execute it, it fires up the API in a container, it fires up the front end in another. Really great. So this application, pretty simple, allows me to log in. It has a light mode, a dark mode, an About Us page, products page, and a home page. Products are, as you would expect in any storefront. Who doesn't need a Catflix entertainment portal, right? I'll throw that in the cart. You'll notice that I got a JavaScript prompt, so the cart functionality is just stubbed out. There's nothing exists there, so clearly this is a work in progress. Now, I do want to jump over to my other demo, but before I do, I want to kick something off because it's going to take a little bit of time here. And this is where I'm going to first start with a very brief overview of GitHub Copilot, because we're going to look at a lot of the things that Andre touched on in his presentation. First, I want to touch on custom agents. Custom agents, I love this feature. This is the ability to give an agent a persona, right? So I can create a custom agent to be a product management expert. I can create a custom agent to be a quality assurance expert, right? I can tailor the entire experience of interacting with Copilot and how it responds and how it reacts. Prompt files, templated, Andre touched on this a lot, templated instruction sets for what we want Copilot to do. Chat instructions, very similar to custom agents, but they tune it a little bit more scoped to the chat session that you're having with Copilot. not so much the entire persona of interacting with it. And then there's MCP servers, which give connectivity to other AI functions and prompts, but also it gives Copilot the ability to connect into systems that I as a developer would need to. I'm going to demonstrate two today, the GitHub MCP server, where Copilot can interact with GitHub directly, and the Azure DevOps MCP server. That's going to be my other demo, where Copilot can interact with Azure DevOps. And so I want you to look at, and then tool sets are just the things that Copilot can do and that I allow it to do. So if I have a great example is giving it access to my terminal so it can run commands on my behalf. So look at custom agents and chat instructions as falling within the context engineering umbrella. They're not quite the depth of context engineering that Andre was talking about, shaping an application and the expectations for the application. I will share, or I will highlight signs of that in this demo. But this is really about shaping the context of Copilot itself. And that's a little bit different, but again, within that umbrella. Prompt files, probably pretty easy to determine. That's a part of prompt engineering. And then MCP and tool sets, that's just the extensibility of Copilot. So what I need to do now is really quickly, I'm going to show you the very first prompt file that I'm going to be working with. And this is pretty cool prompt file. I'm going to bring it up in a more readable format here. Okay, so this is going to use a coding agent. And I want to just highlight something really quick. I have the agent that's in my screen that you see here beside me. That's my paired programming experience. That's the agent that works alongside of me. If it needs authorization to do anything, it's going to prompt me for it. If there's any uncertainty, it's going to return to me as the human in the loop for clarity. Whereas the coding agent is a fully autonomous coding agent. Now, what I want to highlight here is both the context and the prompting that's being done. So this prompt file is really going to say to Copilot that, hey, I want you to do a demo with me, right? That's what we're doing here. And it really touches on the fact that experimentation can be extremely difficult. I want you to think about this for a moment. Here's the scenario. My product manager came to me and wants to see this shopping cart implementation, but she doesn't want to see a single implementation. She wants to see 4 different versions of it so that we can select the best path to take forward. Yeah, right. That happens today. Of course not. We can barely, at times, push our way through to a single version of any particular feature. And quite often, due to time, we end up pushing, mediocre results through because we don't have time to do anything else, let alone create 4 of them. So what this prompt is basically going to do is it's going to set this current context of what I'm asking it to do. I'm demonstrating the coding agent. I want it to perform a certain task. It's going to share the current state. Bottom line, this app doesn't have a shopping cart. It's going to share a goal that I want it to complete. And I think the most important, there's a couple things I want to call out here, right? It's calling out some specifics. It's giving context into our expectations. I'll pause there to say the best results from AI come from the pairing of strong, well-articulated intention and clear context as to what we need Copilot to be aware of in order to complete the task to the best of its ability. So we're going to be providing both our intentions and some context. Instructions, I think that this is pretty much the main one that I want to call out. It's going to create 3 different visual designs of this shopping cart for me so that I am freed up to go off and do something else while it's going to be working on that crazy ask from my PM to have multiple versions to choose from. Front-end architecture, here's something that I think is pretty neat, right? This is providing context to Copilot to say, hey, here's our architectural diagrams. Here's what we expect when the application needs to be built. So we're giving it detailed information. And then on, details about the specifics into specifications, key features to implement. I want to pause on success criteria though, because success criteria is absolutely critical to something like this, because what will happen if I don't have success criteria. It will follow my instructions one time through and it'll spit it out, and it's likely going to be okay, maybe. But when you have success criteria well defined, your agent's going to iterate it with itself until it meets that criteria. So it's kind of like having acceptance criteria in a user story that the human developers always had to work until they met, right? Very similar. Having success criteria is instructing AI that you're not done and we're not good until this is met. And then just additional details on the implementation. So I'm going to run that. And we're going to just spend a little bit moment here because I do want this particular prompt to finish, because then it's going to basically have everything teed up for me so that they're working autonomously. So Copilot, this is its first prompt, so it's just going to spin it up. It was asking me if I wanted to start one of my MCP servers. It's taking a look at the tools that are available to it. And now you're going to see it starting to gather context from the environment, right? It's checking for relevant instruction files. You're going to notice that it's reading information about the front end. It's reading information about the architecture. So because I've got a prompt that gives my intention dominantly with some context, it's using that information to determine, well, is there additional context that I need? And so you'll notice I didn't say go look at, or sorry, I actually did. I said in the document, it does have look at the architecture documentation. And so you did see that. Here it's starting to formulate a plan, right? It's starting to take a look at what I've asked it to do. And it's basically knocking out a order of operations. GitHub Copilot recently announced a new mode called plan mode. And I'll encourage you to think of it this way, right? When we're building something, we have say we've got a feature and it's got the specs that we need to meet, and inevitably though, we have to think about how do we implement this thing? What is the sequence of events and things that need to get done to build, right? So this plan mode is brilliant for fleshing out what does the implementation look like? How do I take this thing and make it real? Really cool. Okay, so I'm going to just open this up really quick. The prompt is done. So basically, it's created its implementation plan. It's gone off to GitHub. It's connected in. It's created 3 different issues, actually 4. I think it creates an epic with 3 items underneath it. And it's going to go off. It's going to do one that's a badge plus 2 column. It's going to do another one that's like a floating pill plus a card stack. And it's going to do a minimal version with just an icon and drawer summary. So I don't have access to this tool environment. Okay, what's going on? It didn't connect in. One quick sec, sorry. All right. I'm going to keep moving on because I did have foresight and I've got this completed demo already in another screen. So rather than troubleshoot live, I'm going to move on. Such is the nature of working with AI and demoing it live. So pardon that particular mishap. We will come back to this demo though of what it looks like to have fully. Now I got to get this going because what I want to highlight is something that was mentioned earlier. Andre, you were given that vision of the developer being almost puppet master, like working across AI. What I do want to highlight, and I guess I'll jump over to it really quickly here, is Agent HQ. That's exactly what it's. No, something's going on here now. Okay, I'm going to carry on with the next demo. I will come back to this to show you the results though. So the other demonstration, the other demo environment that I have is really vanilla, and I'll explain why. I've got Visual Studio Code. It's blank. We're going to start looking at using Copilot as a thought partner for working with a backlog. I've worked with folks in product management all the way through to operations throughout my career. I know that product managers, they're not very used to development environments, right? I know many that have used something like Notepad++. I know a few that have dabbled with something like VS Code. So I really try to start with a clean slate here. What I have is a very simple layout, just VS Code. So at this point, it's not much more than a glorified text editor. However, I do have 2 extensions installed, GitHub Copilot and GitHub Copilot Chat, and 1 MCP server to connect into Azure DevOps. And so as a product management type person, I likely often live in Azure DevOps. This could be the same. This exact demo could work with GitHub directly via issues. I could work with Jira and cards in Jira. I'm using Azure DevOps here in this case. So this particular project, if you've read the Phoenix project, you're probably familiar with the term or with the name Parts Unlimited. This particular environment is modeled after that organization, which was a automobile parts seller. And this is representing the team that's building the web front end as well. So it's a pretty detailed backlog. It's got sprints, iterations, all defined. You know, this team's doing well. They've got their sprints on the go. Now, from a PM perspective though, right, it can be hard to break down a epic, something big, into features and then further into user stories. I've done a lot of agile coaching throughout my career, and I'll tell you, this is probably one of the key areas that I've seen organizations struggle the most with, is how do we break down an idea into something that's actionable to build it? And that's, you know, that takes a certain kind of person to be able to do effectively. So we're going to emulate what it could be like being a PM person to break down a new epic. I know that in this application, we don't yet have payment processing. Payment processing, that could mean many things. There's going to be security requirements. There's going to be a variety of payments. You know, I could probably sit here. I could probably bang out a, you know, do something like a mind map or something and around the topic. And, you know, I could probably burn a good day just thinking about what should my features be, let alone breaking them down into user stories. So I'm going to jump back over to VS Code. And the very first thing I'm going to do, why I wanted to mention custom agents, is because we're going to create one real time here. So I'm going to create a custom agent, and we're going to call this just PM Expert. Okay. Now I got a prompt here that I'm just going to copy over. And what I'm going to ask Copilot to do is build its own persona, right? I do want to be mindful in sharing. This is not a very well articulated prompt, right? Andre mentioned that as well. Like you get like garbage in, garbage out with AI. However, I'm clear in terms of my intent. It's not, I could be peppering into this and giving it real deep specifics. If I had a definition for my organization of what an agile project manager was, I could feed that data in as context, and it would use that in its determination of how it should behave. But we're going to just keep it pretty simple. So what happened is I created a new agent. It's just a templated markdown file. You can see that it's asking for describe what it does and then be descriptive in terms of how you want it to behave. We're going to just top this off really simply and let it determine for itself what it thinks an agile product management expert is. And it's going to build that out for us real quick. And so another thing I'll call out too while it's working, there's no context in this application. This was just nothing but an empty folder. It's not a repo. However, over time, you know, again, Andre mentioned that you start to build up these artifacts of prompts and, you know, and custom agents and chat modes, et cetera, and they start to shape context even deeper over time. And so something like this should absolutely end up making its way into a repo, and something like these, you know, these custom agent definitions can be versioned, revisioned, and then shared across teams and people. So I'm going to just open this up in, again, a bit more readable of a format. Let's see what it came up with. Again, pretty simple prompt, right? So I said, it's coming back and saying I'm an agile project management expert specializing in work decomposition, backlog refinement, and Azure DevOps workflow optimization. When to use me, great information, right? Epic and feature decomposition. We're going to look at that. Backlog refinement. You know, you can use Copilot to ask questions like, are there any items in my backlog that are poorly defined? As an example, creating work items, we're going to see that do that thing. What I won't do, you know, I didn't specify that didn't want it to do anything, but based on my simple prompt, it reasoned that these are probably things as an agile project or product management expert I don't want to do. So it's not going to be writing code, or it's not going to be discussing implementation. I mean, we all know how frustrated we get as developers when somebody tells us how to implement. We don't want AI doing that. We want AI to implement for us because we're going to tell it how to do it. Gives examples of ideal inputs, expected outputs, tools to use, like super, super cool. So I'm going to keep that. It created its own persona. I'm going to close that down. And the very first thing I'm going to do is I'm going to select that PM expert now. So you can see in my selection agent plan, ask and edit, that's out of the box. Now I've got this PM expert that's an agile product management expert specializing in work decomposition. One thing I'm going to do really quick, I'm going to give it all access to all the built-in tools, and I'm going to give it access to the Azure DevOps MCP server. Now, context has been a big part of what we've talked about today. And so I need to start building this up. And I'm going to start really simply by just asking Copilot to list out my Azure DevOps projects. And so because it has it's configured to use the, oh, come on, you got to be kidding me. Try again. Here we go. Come on, Copilot, don't let me down, little buddy. Let's go, let's try that one more time. Oh, the demo demons are biting me hard today, are they not? That's really strange. Okay, PM experts fine, configure custom agents, that's all fine. Let me try a different model just for the sake of trying something new. Oh, I know what's wrong. I'm sorry. I didn't say okay. There we go. Okay, we're back in track. List my Azure DevOps projects. Here we go. Okay. Here we go. So Copilot is asking the Azure DevOps MCP server to go off and use or list out my projects, the query that I asked it. I'm going to flip back to the model I was using because it tends to do a little bit better job, right model for the right reason. So now that I've got my Azure DevOps projects listed, as a part of the context, it's now aware of my projects. Remember, there's nothing in my environment here that represents that. So next I'm going to just say, listen, I want you to work in parts unlimited under the default team only. And so I'm setting a little bit of scope here, but again, it adds it into the context. So now when I'm interacting with Copilot, it's only going to be thinking in terms of parts unlimited under that default team because I've asked it to do so. All right, now, so we have this agile product management expert right alongside of the road, or right along for the ride for us. So I'm going to do another just quick list out my backlog. Now, when I'm doing this particular prompt, something interesting is happening because I'm going out and I'm asking for the backlog. So it's going to bring back a little bit more data, and it's probably going to chunk that data. I think I saw it did a top 50. It's probably going to issue another one to bring them all in. Here's why this is important though, because now it's bringing the awareness of my backlog into the context of my session with Copilot. And so now it has an awareness of what's in my backlog, and I can start querying against that and working with it. Once it pulls that back, we're going to go and start. Okay, here we go, querying out. So remember I said there's no implementation of payment processing. Okay, so it brought back 50 work items. It's going to list them out. It's going to probably just give me a nice view. I'm surprised it didn't list them out. Anyways, here's what we're going to do next. I want create me an epic for payment processing. Include all information. Yeah. So I'm gonna, that include all information is just a little bit of a prod to look a little bit deeper at the epic layout. If I was to just say, create me an epic for payment processing, it's likely to go and take a stab at it. It's probably going to give me a decent title. It's probably going to give me a nice little description. But if I push a little bit harder and say include all information, it's likely going to go and try to determine business value and probably effort value, etc. So let's see what it's doing here. It's going to jump. It's thinking. I'm really upset because that first demo was probably the biggest one and the most impressive one of the fully autonomous coding agent. I really don't understand why that didn't kick off. Maybe if we have time, I'll try to initiate it again, because what I really hope to show you there was the agents working in parallel and how, look at this, geez, there we go. Okay, apologize for technical difficulties. Anyways, it went on. So look at the information that it broke down here. I'm gonna full screen this for a minute because I think that this is pretty potent, right? Like it looks pretty decent. It's understood that like I didn't provide it information as terms of what processing or payment processing is. So it was able to determine, and it was able to make a pretty decent overview. Like I said, because I asked for all of the info, it went through and talked about things like business value, success metrics, scope. What I don't know is why it didn't create the epic in Azure DevOps. So I'm just going to ask it to do it. It's been a little finicky for me, which is just how it goes because I've run this demo like 20 times over the past week. It's just figures. Yeah, something's, there we go. Okay. I'm going to give it full, I'm going to enable auto approve here. And for the sake of time, I'm going to just allow it to issue the AZ command. What I think is really interesting is for some reason, it's not using the Azure DevOps server, MCP server. It should be. And that's, again, just part of the craziness of demoing AI live is that it's a little, it's never the same twice, I guess. Okay. So it says it created the epic. Okay, it did not. The user is not authorized to ask this. That's the hell is the user AAAA? That is, I'm going to try this one more time, folks. List out. List out my IDEO projects. Thank you for the love, Martin. I'm feeling like I need it right now a little. Okay, I'm going to just blast through this really quick. We want to get back to that scope to the team, and I'm going to jump right into the asking to create the epic. All right. The payment processing, include all data. All right, come on now. You gotta be working. Okay, here we go. So it's going to create the epic. It's working. It's going to do this for me. Come on, little buddy. I know you got this. Do it. While that's working away, let me jump into some of the other topics that good. Okay, here we go. I'm gonna allow it, I'm giving it full access to Azure DevOps. I'm showing a lot of trust into AI that's been giving me a hard time, but that's another story. Here we go. Created the epic payment processing. See what it did. It did everything that we need for the fields, gave an overview, talked about business value. Oddly enough, that's something that most organizations I've worked with seem to ignore is what's the business value of this epic. Same with estimating business value for user stories as an example. In scope payment gateway, so it's kind of reasoning. And if we look back, it even gave me a link to Azure DevOps. I've actually never seen it do that before. That's kind of cool. If I go over to Azure DevOps and refresh, we're going to see, there we go. We're going to see on the epics backlog new user item or that new Epic payment processing system. It even went in, started tagging as it felt appropriate. Of course, again, I didn't provide that detail. You can always instruct it as to what you want it to do and how you want it to do it. This is a pretty simple prompt, so it determined that for itself. But I'm happy with this as a, I mean, the priority is right. It's a payment processing system for a web app that, sells products. So that's pretty critical. And I'm pretty happy with the detail, the information that it did give. I'd like to see some acceptance criteria maybe, but let's continue on. So now that we've got that Epic in place, right, I can start to build upon that, right? So I can say, and again, we're going to just be super simple here and let Copilot kind of reason over this for itself. I'm not going to be very articulate in my prompt. And so I would say, let's recommend features for this Epic, right? And so notice the little subtle change there. No, recommend. I didn't tell it to create, right? I'm asking it to recommend them. And it's pretty sensible what it's coming up with, right? Payment gateway integration, checkout experience, payment method management. Like these are things that, again, a PM like individual could be spending hours just kind of brainstorming through. And if I want to get, not let alone getting all that information into Azure DevOps, and if I wanted to do that, I can simply say, create these in ADO, ensure the linkages to the Epic. And it's going to go reason over this. Now, I'm going to move on because I spent a little bit of time troubleshooting and whatnot. But what I want to highlight here is I could use this in a directly connected method via MCP to Azure DevOps. I could do this into files that I want to just do locally. I can do that brainstorming of breaking down an Epic all the way down into user stories in minutes versus hours. And what I've seen a lot of organizations start to do is take the first crack this way. Because again, they're learning, right? They're not fully onboarded, they're not fully frontier, but they're starting to embrace AI and it's starting to, help them do their function. So I see a lot of organizations experimenting with this as their first pass and then refining from there. And the feedback that I'm hearing is it gets them 90% of the way there super quickly. But I will add, they're far more articulate in their prompting than I am, and they're bringing in context that relates to their organization and whatnot. So anyways, you can see Azure DevOps Copilot's running off, creating all these elements in Azure DevOps. And if I jump back over just to do a quick refresh, we're going to see that payment processing system. You're going to see the links starting to come in. So there's the first feature that it's created. And so it's going to keep chugging through, creating those features. And I could be brainstorming with it. What I should be doing, and I think that this is really, if you look in terms of spec-driven development, what I really should be doing is creating spec artifacts that can later be used by a developer so that they can translate that artifact into a AI executable format via prompt. But anyways, so there is a definite benefit to PM folks to being able to use this as just a thought partner, but that value goes so much deeper if they actually connect it into the environment for which they work in. So you can see I created an Epic and fleshed out 7 features. And if I were to go and say, now create the user stories for all of these features, it'd create that full breakdown. Now, I want to come back to the other demo environment. I'm going to come back to my code spaces here. I'm going to talk a little bit about the developer now. I think I just launched that by accident. There's so many things that we do as a developer that is time consuming. I did want to touch on, I did want to touch on some of the modes for a minute, right? Agent mode is your paired programming buddy. Like 90% of what I do is with the agent mode. Plan mode I touched on already to help me kind of flesh out how I want to approach a problem. I do find myself using ask mode a lot. And ask mode is the mode that keeps me in my IDE and prevents me from running out to Stack Overflow or Reddit or somewhere else to look something up. And then edit mode is just really about helping me with in the moment with what I'm doing. And so as a developer, though, Copilot helps me from everything from a single line of code to a full, to a full project, depending on how, again, I've structured my prompts and the information that I've given to AI. But I want to touch on two things in particular. First, even though the autonomous demo failed, I do want to come in and I want to show a prompt file and run this one here real quickly with you. So because we're going to get a shopping cart before I part ways here, we have to. So if I look at this prompt, it's again, right? This is really well done because it's providing clear intention. It's not really going in too detailed into how to do it, right? It's letting the AI reason over that using the context that it has, things like the existing code files, the style, anything that we cite in if we have code, we had code standards as an example. But again, it's following that same pattern. It's given the context. Hey, we're demoing. We want, we've got this web app. Its current state, no cart, the demo goal. I touched on this. I will add though, notice this line here. It's a little bit of a business logic kind of buried into the instruction set, which is pretty neat. And we'll come to that in a minute. This one's a little bit different than the other one that I showed you. One thing I really think is cool about this particular implementation is it's citing out to an image and it's using vision as a point of reference. And so I'm showing it this document right here, this image right here of a cart. And I'm then saying, hey, that's a really good example of a cart for these reasons. Yeah, sorry, it went back into. So it's a really good example of a cart for these reasons. It's a clean design, right? It shows a good example of listing out items, adding an item or removing functionality, adding items with plus minus buttons, etc. And so it's using that image as a point of reference, and then I'm backing it up by saying why that image is a good example. And then I'm going through and doing the technical requirements, just like the other prompt file that I walked through. So I'm just going to run that one and run it in a new chat. Actually, I'm going to start here, run that in a new chat. And so I'm going to pause here and ask you just to consider the fact that these three agents had run in the past, because I want to go back to something that Andre said. I really believe that the future of the developer is that of an orchestrator and that of a validator, right? And when I say validator, I don't mean in the same way that a quality assurance testing occurs, but I mean validating the results that are coming back from AI. Is it what I wanted? Is it following our coding standards? Is it well architected? The following conversation after Andre's presentation, there was discussion about that, and you've got to you have to iterate with AI too. You're not always going to get the best results right off the bat. One thing that I get asked a lot is when I create something with AI and then I run a code review using AI, why is it coming back with things that it should improve upon? Why didn't it catch it right off the bat? And the truthful answer to that is, well, software by its very nature is iterative. It didn't have the context and reasoning that it needed in that moment to make the best first pass. Sounds a little bit like a developer, right? I don't know about all of you, but I've written a lot of code to refactor it down to a little many, many times in my career. And so it's never going to be perfect right out of the bat. Or I shouldn't say never, because it may be, but we're not yet at a point where we can have just blind trust in the results. And that's, again, that second part that we need developers for, is to ensure the quality of what AI is delivering us. So we're almost done here already. So it's gone through, it's created the implementation. I've got it set to auto work, right? But you can always, as a developer, you're not going to be talking to crowds of people and you're not going to be sitting back twiddling your thumbs waiting. You're likely going to be real time analyzing the results of what it's building and taking a look at the code changes, right? Instead of writing the code, there is still a need to be syntactically aware. Like you still need to understand how to read code. You still need to understand how to determine is it good code or not. But what it's really allowing the developer to do is step out of the algorithmic thinking and start thinking about systems. And, developers out there that have a broad awareness of the full life cycle, they're going to fit right into this landscape because it really is a matter of understanding how everything flows and comes together that, the developer will need to be more aware of because they're going to be orchestrating agents doing that very thing. So updating, we're getting there. But anyways, I could be doing my self-assessment as I'm going, validating that it's going properly. I would likely be jumping into agent sessions. So I am going to demonstrate this a little bit. So this is 3 agents that ran a session earlier, and you can see that I had them banging out a cart, right? So you can see it's very similar to what is happening in my own chat, right? Where it's going through and it's determining the pages that need to be edited, the files that need to be created, everything that needed to be run. So now in my paired programming agent, it's running a build. So that means that it's finished. It thinks it's there. So help me if this doesn't complete the build. Okay, it did. All right. Okay, so now I'm going to, we'll let it go for sure. I'm going to run this again and just highlight the cart build. Another example that I would normally share, and I'm getting a little bit short on time, so we're not going to fire this one. One of the things that I really dislike the most about being a developer is unit testing. I'm being honest, unless I'm writing the tests first. I love test-driven development. It's fantastic. But going into an existing code base and being asked to improve code coverage, oh, that's so painful. For a variety of reasons. Some code's just not very testable, right? The term spaghetti code was used earlier. It's really hard to unit test a method that does 12 things. Hopefully that's not the case in your world, but I've always disliked immensely having to go back to write unit tests. That's an amazing use case for GitHub Copilot. So coming back to this demo though, shopping cart icon. That was not there before. So I'm just going to click it in. It had it even had a little bit of humor. Shopping cart's feeling a little lonely here. Browse the products. I can now add that Catflix entertainment portal that I want. It's great. You can see that my icon updated. I went in, and I think this is pretty neat. It's showing me this meter here. I didn't ask for that, but it's basically saying, hey, spend $10 more and you've got free shipping. I'm going to, I need 2 Catflix entertainment portals, and you can see that business logic applied. So I'll pause there to just highlight some of this was determined by itself, right? Some of it thought, hey, this would be really great to include. That whole section of showing the shipping or not. There was no inclusion in my prompt file that mentioned that. So some of it reasons over and determines, hey, this would be a really nice feature to include. And other things like that business logic, it's executing because it was told. The better the prompt, the more clarity, the more, again, articulate your intention is, the better the result. And again, pair that with the right context and results can be fabulous. The context in that prompt was really good too, because I'm giving it an image of a shopping cart. I'm saying, make something that looks like that. I'm giving it references to our architecture diagrams, etc., build instructions. And so here's just an example where using prompt files, I'm going to go back to that prompt file real quick. Sorry, wrong tab. Here's an example where using prompt files can be, full-fledged feature rich. And I do believe I want to go back to the PM topic for a moment, because man, is it ever important. Andre, you had one slide there that I wanted to touch on. You mentioned how in the past, we were very imperative in terms of development. We had to tell a compiler exactly what we needed it to do, and darn it, it did exactly what we told it to do. And then we moved into this era of declarative, where we had these, frameworks and components that we could configure to produce the results. This AI era is really shifting to being descriptive, right? Again, providing that intention and providing that context. I think it's fascinating, because I think the role of product management, breaking down what needs to be done in a very clear way, is becoming increasingly more important. And then I think the role of the developer as that orchestrator is making that translation from spec requirements to executable requirements by AI, which I already touched on. Okay, so I did want to highlight one other example real fast. I'm a little bit nervous of it because I've had a bit of a hard time with the Azure DevOps connectivity, but I'm going to come in and I'm going to create another custom agent very quickly. And this time we are going to create a QA expert. So the mind of a quality assurance expert versus the mind of a product management expert, very different. And they think very differently because they solve different problems. And so for this particular crack, I'm going to do exactly what I did last time. Not a very articulate prompt, but enough. Help me create this custom agent definition. I want the agent to be a QA expert with proficiency in test discovery and test planning. And so, just like last time, I'm using Copilot to create a persona for itself. I could be very, I could create a prompt file meaning exactly what my definition of a QA expert is. I'm relying on Copilot to reason over that and determine that for itself. And so it's going to go through, and again, it's looking for existing elements to include in the context. This is a bare bones folder with not a whole lot in it. And so pretty much everything that it comes up with, it's reasoning for itself. All right, I do want to take a quick look at it with a more readable format. So when to use me, that same thing, right? Its purpose, when to use me, what I don't do, right? Like it's not actually executing tests. That's good. That's not its purpose. Ideal inputs, user stories or features that need test coverage, expected outputs. And so now I have this new agent. I'm going to keep that change. I'm going to save it off. And yeah. And I'm going to go back over to my QA expert, and I'm going to repeat that same process, just giving it access to the tools. But this time I will say okay. Okay, so now I've got QA expert. Okay, I'm going to start with, again, building up that context, list out my ADO projects, giving it the scope that I want it to work within my Parts Unlimited project. And this time I'm going to do something a little bit different. I'm going to ask it to list out all the product backlog items and related test cases for my current sprint. And so as a QA mind, I should always be worried about, are we getting effective tests, or do we have effective enough test plans to provide full coverage for any given feature? Not easy to do. I want to just pause for a really quick thing, because you might be thinking to yourself, geez, test cases and test plans and test cases, that feels a little old school, and it's really a practice that originated in manual testing. I have to say though, nothing is a better roadmap for automation than test cases that get run frequently. And so I still to this day believe that having a solid test plan and knowing what you're going to test is needed. We're not yet at the point where we can say, hey, AI, just test this for me, though we're getting there. I'll show you what I mean by that in a second. So look what it did. It came in here and it came back and it said product backlog items 4, test cases 4. Didn't give me the greatest. Let's take a look at something in Azure DevOps itself. If we look at our sprint, our backlog items for the current sprint, we can see let's pick on one. Number 54, okay? It only has one test, but it's provide tentative durations for shipping. Let's see what Copilot thinks about that. So product at PBI 54. Do you think PBI 54 is effectively tested? And so now it's gonna go no, right? It already has them in context. No, it's not effectively tested. Here's my analysis, right? Current test coverage, none. There are no test cases currently linked to PB54. That's actually incorrect. This is a critical gap in test coverage. But looking at the user story as a test, QA expert, I can start thinking about, well, how should I effectively test this, right? What test cases do you recommend? So I just want to kind of walk back for a second. I know we had some hiccups, but what I was able to demonstrate is a full shopping cart implementation. I was able to create not one, but two custom agents. I was able to query in to create, or sorry, interact with Azure DevOps via Copilot to create an epic, break that down into features. And here I am working with Copilot to analyze, test coverage gaps in my product backlog. I'll tell you right now, the sum total amount of human effort, if I was to try to do everything that I did today in less than an hour, is probably nearing a week's time. And so, yes, it was a little bit rocky, but what I was trying to demonstrate here really isn't, the happy path to success, because nothing in development is the happy path to success. There's always hiccups to overcome. Demoing with AI is no different. But what I'm really highlighting here is that with creative experimentation, AI can accelerate anything across the software development lifecycle, because it's not about doing for the human. Andre touched on this. It's not about removing the human, it's about empowering the human. And so I made the comment earlier, when we're working to get started, the most important thing that we can be asking ourselves is, how can AI make us better at what we do today? If we think too fast, right? Like if we're sitting there going, how can AI do my job? You're asking the wrong question and you're trying to run before you can walk, right? If you ask yourself, how can AI make me better at what I do? Then you're going to start to kind of walk before you get that jog going. And before you know it, you'll be jogging and then full out sprinting. So kind of coming back, I'm running a little bit short on time. So I do want to sort of go back to the far right of the DevOps spectrum and talk a little bit about the operation space. I think the Azure SRE agent is a fantastic example of where things are going, right? So this is a fully autonomous agent that monitors, say, you can connect it into your incident management system as an example, and it'll do incident automation. It can do things like scheduled workflows to, execute on routine tasks. It can do things like continuous health monitoring and start triggering alerts if things start to go south. It can even initiate things like health or self-healing sequences to remediate a problem going on. Even little things like AI root cause analysis, right? Operations folks don't love getting woken up at 2 a.m. I don't think anybody loves to get woken up at 2 a.m. What if AI agents could monitor that any given system and keep it into a healthy, resilient state until the morning, alerting the humans that something is potentially wrong, right? So it's be doing like this preemptive analysis that and proactive analysis of the environment. That's amazing, right? Like that's straight out of sci-fi, and that's here today. Moving forward, I touched on, I showed a number of models. We created a custom agent. The models are getting better and more capable by the day almost, it feels, but that's a little aggressive. But we see the models are, coming out more frequently. They're getting better. Things are emerging like spec-driven development and spec kit, where It's really embracing that context engineering paired with prompt engineering mindset. It's amazing what's what's happening before our very eyes. And so when it comes down to road mapping this thing forward, I want to go back to where I started and thinking about the value stream map. Ask yourself, where are the things that are slowing us down? What are our pain points? Where does building software suck? I know it does somewhere, right? And ask yourself then, is there some way that we can apply AI to make it a little bit better? And then just like everything that originated in the Agile movement, that led to the DevOps movement, now into the AI era of Agentic DevOps, continuous improvement's the way to go. Start small, keep iterating. My personal opinion, and I know I'm biased with the products that I use, but I'm going to call it Copilot, but whatever coding assistance you use, start there, right? Have that AI assistant along for the ride and leverage it to try to make your daily life a little bit better. And before you know it, again, you're sprinting your way there. Again, I apologize for not being there in person, and I'm sorry for the little demo hiccups, but hey, we got through it. And I hope that I did enough to give you the gist of what I'm trying to say here. AI is going to be applicable across the entire software development lifecycle. It is definitely redefining all of our roles, but right here, right now, let's start with making sure that we're focusing on being better at what we do. And I'll close with this. We can prevent making that past mistake for sure. But I want to issue one subtle warning here. There's a very big difference between being dependent upon something and achieving mastery over it. We do not want to become dependent on artificial intelligence. We need to achieve mastery over it. And that's what I'm getting at. Use it in your day-to-day. Bring it along for the ride. Don't have it the driver. There's a reason we call it Copilot. Keep being the pilot. Thank you. I wish I could, be there to chat with you a little bit more and shake hands and get to know you, but I'm coming at you live from Ottawa here, so it's wasn't quite able to do it. So I'll pass things back over to our MC, and if there's any questions, fire them up. You have an MC? Hello? Hello, Vancouver NPR?
Perfect. Okay, can you hear us now?
Ah, there we go.
Okay, sorry. Well, yeah, you missed actually the most important part. So what I just said, that actually we have to think about the entire life cycle. You cannot just think about the one specific tool only. We have to think. We have to have a system thinking, and this requires completely a different paradigm shift, right? We have to completely think differently about how we build software in the near future. So. But the bottom line is that the train left the station and the thing is actually moving. This is real at this point. It's going to become better and better. Do we have questions?
I have a question. I just want both of you, Andre and Chris, to give me the definition of the IP, intellectual property, that is being built inside the organization. Because, you've been showing us here emulating different personas, product manager, developer, DevOps, etc., and they're being, passing to each other something, right? And so what should we be storing, just prompts and context, or, the code is still something that we do care about? Thank you.
Oh, of course. The first thing I want to say is I think organizations historically have undervalued source code. And I've always thought that that's such a mistake, right? They've always valued the thing that gets built, but without the source code, you have no mechanisms to build it. Source code is becoming a massive asset. And here's a really interesting thing about it. It's also becoming a form of data because source code is now feeding into artificial intelligence as what? Context, right? And so not only is it a valuable asset and doesn't like it remains being our IP for sure, but it's becoming even more increasingly more important because it's now a form of data for AI to reason over. And then secondly, as far as what IP should be stored, my short answer is any artifact that's being created that helps the process of creating software. And if it's has value in terms of reuse or information, or it's a part of the construction, then it's all your IP for sure.
So my take on this is, and I agree with your last part, but I believe that the code itself, the code actually represents the business value by embedding the business rules and the workflows. And this is currently not part of the, or becoming not part of the code, but part of the prompt. So code is becoming commodity. Your IP in the future is actually your prompt and set of prompts. It's not, and it's way more complicated. Obviously, what Chris was showing, it was very simple examples. But if you really build a large applications, there's a whole hierarchy of prompts that needs to be in place. This is actually what where the business value really is embedded with, not so much in the code. Sorry for being brutally honest, right? But you could see, it could actually, this code could be generated within, like Chris did, the 3 agents within 1 hour, right? And how long would it take you actually to build this if you would have to do it like without help of AI? This would take weeks, right?
True. And Andre, I think you actually, you might have just helped reframe the way I was thinking about this a little too, because the thing about having the prompts as the primary IP is that the prompts can be used to recreate the code.
That's right.
It may not be line for line identical to what you had, but historically, the reason that code was so important was because without it, you couldn't recreate. But if you have your prompts, then you can recreate the code, therefore recreate the binaries and assets.
Yes.
Good view.
And as a matter of fact, it actually answers your previous question about that, because when you're building this particular application and you find that there is something missing, you regenerate the code. Previously, before you find that there is an issue, it took potentially weeks. Now, refactoring of the code that actually was built over several things could take actually even longer. With this, you just regenerate the code. It will take you an hour. It won't take you the weeks, right? So, but then, just not to be clear, what is important, the architecture of those systems is important. So there's the second step in the life cycle, because it means you need to, and what Chris was actually defining, the features and splitting the stories, that's where teams always struggled. The same thing here. The system needs to be composable. So in other words, if you've got several developers and each of them are going to work on certain subcomponents and making sure that all these components work together, that's where the art is, right? That's where the architects need to think from the perspective of how AI can actually build those applications, but in such a way that they are independent or relatively independent, and what the integration between these systems are. So it's totally different way of thinking about how we build and how we actually starting working with the software. This is why I said it's not easy. I know, because I can see this like every day. It took me a while also to figure this out, but I think now I know. Now I really know, and I like there are potentially different ways to look at the future, how the future is going to look like. Honestly speaking, I am absolutely confident that that's actually the right way. That's how the future is going to look like. And actually, we see this. Like in my team, we start building those. Our first project was using the traditional approach with traditional software development lifecycle, and we added AI. Well, it worked. And it's okay, it's working, it's nice, and so on. And yes, it does actually the thing, but it took us a month to do that. The new application that we did, it took us 2 days. I mean, literally less than 2 days, and we got actually working application. So, and again, as I said before, it's a numbers game, right? So within the same time, you can regenerate multiple solutions, and this gives you actually the confidence that in a relatively short period of time, the number of of iterations that you need is going to be shorter. The other thing that I want to also respond to your question, I know we are out of time, and Chris is actually in Ottawa, so it's very late over there. So we really appreciate this. But the thing is, there's this concept that we are also starting implementing, which is called adversarial agents. So one agent is building, the other one is breaking it independently, right? So a few iterations, you got actually working software according to the context prompt that we actually defined at the very beginning. So this is continuous improvement. The human is in the loop, like Chris was just showing, right? There is you need to answer. So it's not going to be magic that okay, there is no humans over there, and applications just build them themselves. Humans actually take different role. They're more strategic, thinking how to decompose the system, how to start building them, because the way how we did it until now in traditional development, where humans were actually in the center and writing the code, and where humans had all those limitations, and we had to all those processes to overcome the human limitations, this is actually disappearing. It's actually empowering people right now to focus on the stuff that AI and machines cannot do, innovation. Right? One more question. Here we go.
Hi, thank you for the presentation and everything, and saying what a lot of people are actually starting to believe. It is like what you said, number game. Like, I don't care how it got there, that it actually works and does what it's supposed to. Speaking as a designer, where designers do fall in all of this? Where do they start? Because it's interesting to understand, because working with developers, building my own website by myself in React and not HTML and CSS, I didn't need to understand the code. I just needed to work, to make the functionality do whatever it does, and just give it the proper prompts. So, and this is what I'm telling the students, my students, or people, is like they're asking constantly an AI, and they're saying, can I use AI? I said, first you need to know the craft in order to understand and how to talk to AI. You can't come jump into AI and say what it is, but still, when are we going to be reaching to the point that developers won't need designers won't need developers?
Chris, you want to answer this?
Yeah, so, I think we all have a different form of cognitive load put on us based on the role that we're in. Developers, notoriously high. Testers, same. If we were to try to take the designer and merge them with a developer, right? Just right here, right now, then that's going to be too much for any individual to do both of those things very well. Will they be able to get by? Maybe. My point here is that we always need the mind, right? The human, the creative element of it. We always need the way of thinking and way of looking at something. Designers, you've got that, you bring that human element in, things like user experience and the whole, flow of what the user should be experiencing in working with a piece of software. AI can emulate really well, right? Like my demo, I showed a shopping cart and I said, design it like that. I think the role of the designer is going to be somehow embedded in the process of prompt engineering and context engineering as well. I don't know if there's a specific lane for it, but I don't predict a future where those skill sets aren't still going to be needed, but they may be put to use in different ways.
Yeah, my take on this is that in one of my slides was we still need domain experts. The systems actually needs to have someone who can explain exactly what is needed. So the prompts and prompts optimization. Well, from designer perspective, actually it empowers you in the way that actually this didn't happen before. Because by changing of the prompts and the feedback you're getting from the systems that analyze behavior of the customer and what they do actually on the site, you can optimize these prompts. As a matter of fact, you can constantly seeing, what's happening over there. You can actually refine these prompts over and over and over again until the time where actually you can see that, the people are happy and your sales are going up and whatever you're trying to achieve. but over a period of time, this will be changing as well. The user behavior is going to start changing, right? The sites might be start looking like obsolete and old and old-fashioned and so on. You don't need to regenerate entire code. You just change the behavior by changing the prompt. So the understanding of the, and this is not only for designers, this is actually for every single role. You are the experts. Now you really focus on the stuff that previously you didn't have a time on, right? Because you were too busy, you had too many projects and so on. Now you really start refining that, and the system is actually helping you to analyze this data. Like how many people, let's say customers you were able to watch from that specific demographic at the specific time of the day and specific day of the week, which might be different for this particular demographic. It will analyze and it will tell you, oh, during this time, you might actually change the interface, right? Or something like this, because this type of customer, right? And there's another thing which is also important. When I was younger and I was working in a startup as a product manager, one of the biggest challenges for me was, so we developed this perfect product and we want to actually market it to the entire market, right? To the entire segment. But then we had 3 customers who were really highly paying, and they were just wanted to make changes to the application just for them. So now I had a choice. There was a paradox, right? Because from one side, I want to serve the entire market because I want to sell this product to thousands or millions of customers. But then I've got the 3 ones at this point, at this early stage, who pay, and I have no choice, and I have to actually take this. With this, I can have 300 different versions of the same application for those different customers that they really want to have this application, and then have a one generic version of everybody else, and actually is maintained by AI. Like normally, we will not be able to do that because maintaining those applications and the overhead administration, it would take ages, and to connect the dots and remember what's going on over there, AI is actually helping with that. So it's actually empowering us to do way more and start thinking about our products in a way that nobody thought before. It's opening really the new frontier.
Yes, thank you.
Okay.
One quick question.
Do you need an agent for everything? Like, there's always going to be some situation like networking, maybe the network rules are in the wrong order, or there's some other input. And especially with the platform, are you assuming that the platform works? And if the platform doesn't work, how are you going to do the failover? Like, I don't know, we save cost by not having another data center location and stuff. So there's all of these different things around it. And for it all to actually work, do you need agents for everything, for network rules, for monitoring as well? We use separate systems for monitoring. We use Dynatrace. Does Dynatrace need the agents to connect into the API for it? Does that need to all be redesigned as well? Yeah, do you need an agent for everything for it to actually work properly?
Chris, you first.
My short answer at this point in time is no. I think, I don't think we're going to have a need for agents at that granular, right? But I think it's going to be more, maybe a little bit more domain aligned. So I'll use the Azure SRE agent again as an example, right? Like it can connect to a variety of incident management systems, right? So it's an integration to, and it can reason depending on the integration to respond like that system would expect it to. And so I don't think that we're going to need an agent for every specific, third-party tool that we need to be monitored, but I think rather, monitoring and alerting, like again, a bit more of a domain approach. But we'll see. We'll see.
Well, and I agree. As a matter of fact, if you think, well, we should actually think about those agents as the humans that we would normally employ, right? You are not going to employ every single person to do every single thing. Agents, the difference between agent and copilot or chat is that agents actually can reason and select the tools that they need to do the work. So those tools and skills are those that specifically, for example, you might decide that, okay, this is not really agent, but this these skills are actually available over there by other agents, and agents can do it themselves. So it is really up to the designer at the very beginning, the second stage of that life cycle, where you define what agents you will need and what skills these agents are going to have. So you don't want to build millions of agents, right? You want to have only those that you would normally be employing, specifically for your need, right? All right. So, all right. Thank you very much, Chris. Again, this was really fantastic presentation, and it was really validating what I was saying, and good to see that Microsoft has all these tools. Again, many thanks to Microsoft for hosting us today and giving us, and we are already over time, right? So we really appreciate this. Next year, we will be focusing more on AI DevOps. So we'll be inviting more speakers and people who are obviously going to provide some information. If you are interested in and you would like to speak, please let us know, and we'll schedule you as well. So again, thank you very much. Thank you very much for coming. Thank you.
In fact,